A digital display shows the current date as an 8-digit integer consisting of a 4-digit year, followed by 2-digit month, followed by 2-digit date within the month. For example, Arbor Day this year is displayed as 2023-04-28. For how many dates in 2023 does each digit appear an even number of times in the 8-digit display for that date? Okay, so we want to count 8-digit dates count starting with 2023, and each digit appear twice. So 2023 is followed by 4 more digits, and we can immediately observe that. So those 4 digits should consist of 1, 0, and 1, 3, and 2 of the same kind. Let's call them A and A. And we're going to do a casework. Let's start with checking the cases for the first digit of the month. There are 2 options. It's either 0 or 1. Let's start with an easy case. So let's start with when this is 1. Let's count the cases when my date starts with 2023. It's followed by 1. And then I know that the last 3 digits are 3, 1, and 0. Let's have a look at the second place. Since there are 12 months in a year, this digit cannot be 3, right? And then that means I can't use 3 here, but other than that, I can use anything and it will work fine. So for example, my number can end with a 130 or 103 or 013 and 031. You may check and see that all these dates are valid. Okay. Now let's work the second case when the 5th number is 0. Or in the second case, 2023 is followed by a 0. Now the remaining 3 numbers then should be 3, A, A. Okay. Now if this 3, let's do a casework for this one as well. If it's followed by 3, then A's can be 1, 1, 1, 1, or they can be 2, 2, right? And if it is followed by an A, or if the number has to look like 0, A, and 3 and A in some order, now we can easily observe that since there are at most 30 days, since there are at most 30 days in a month, this part is at most 3. And I think we can make a casework on whether this number is 3 or not. And that may be a good way to approach here. So I know I checked the cases when the first digit is 3. Now let's check the case when this is 3. Now we should have A and A here. And then we can immediately observe that A can be 1. So 1, 3, 1, this also works. Or A can be 2, 2, 3, 2. Or actually, A cannot be 2. Why? Because there are not 32 days in a month, so A cannot be 2. And finally, it may happen that 3 is in the last place. And the other numbers are AA. So AA3, and in that case, 113 and 223 work. And in total, we have 4 from the first case, 1, 2, 3, 4, 5 from the second case, and all in all, we have 9 different cases that work for us, and our answer is E9.